Hello, everybody, and welcome to my channel. Today, I will solve several mechanics problems. So let's start with the problem number one, or question number one. So it says, in a cantilever beam subject to a uniformly distributed load W in Newton per meter over a length L, the maximum bending moment at the fixed support is given by. So we have a cantilever supported beam like this, fixed end. And there's a W, a distributed load. This is the beam. Yeah, cantilever, fixed end. And there's a constant load of a Newton per meter. And the length is L. So the question is, what is the moment at the maximum bending moment at the fixed support here at A, for example? So the maximum bending moment, the resultant force acting on the beam is WL, because it is uniform all over the beam. So WL multiplied by, and the point of application is L over 2. So this is L over 2, is distance, is L over 2. So the moment is W L by L over 2, which is WL square over 2. W L square over 2. So the correct answer is B. This is a simple question, not very basic. Now, the next question, in the analysis of a pin jointed truss, it is assumed that the joints behave as frictionless pins. This implies that each truss member carries only axial forces, only bending moments, only shear forces, combined axial and bending forces. Now, in trusses, members carry only axial forces, tension or compression. So in trusses, members only carry tension, axial forces, either tension or compression. So the correct answer is A. The next question. Let me remove this. A simply supported beam carries a concentrated load P applied at its midpoint. What is the reaction force at each support? So what we have, simply supported beam with a concentrated load midway. So we have a simply supported beam like this. And there is a load P acting midway. So this is P acting midway. This is L over 2. So what is the reaction force at each support? So what is the reaction at each support? So because of the symmetry, now this is as simply supported, we can apply the equations of equilibrium, sigma fx, sigma fy, and moment at one of the supports. But because it is symmetric, the force is at midpoint, so the amount of the force will go to support A, for example, and half of the force will go to support B. So the reaction is P over 2, 4.5 P at each support. So the correct answer is C. The next question, a rotating disk maintains a constant angular velocity. Which of the following statements correctly describes its rotational dynamics? So the disk is rotating at a constant angular velocity. So because rotation happens because of torque. Okay, now because it is rotating at a constant angular velocity, so its angular acceleration is 0 because it rotates at a constant angular velocity. And because, again, the torque is constant, so that means the summation of the net torque is 0. This is analogous to an object moving at a constant velocity. It's in dynamic equilibrium. So because it is in dynamic equilibrium, summation of forces should be 0. And here, because it is again in equilibrium, so net torque is 0. So let's see the options. Its angular acceleration is non-zero. This is not correct because it is angular velocity is constant. Its angular acceleration is 0. That's correct. And the net torque is 0. So B is the correct answer. Its angular acceleration is 0, but okay. So both the torque, the net torque, and the angular acceleration both should be 0. So the next question. When a force is applied at an angle to a lever arm, the effective moment about a pivot is determined by multiplying the force by. Now we know moment is distance by force. This is the definition of the moment. Moment is distance by force. Now the force and the moment should be perpendicular always. The force and the moment should be perpendicular. So if this is a force, for example, and there's a pin here, and the force acts at an angle. If this is the force like this, and we want to determine the moment by the force at point A, so the distance between the force and the point where we want to determine the angle should be the perpendicular distance. So we can extend the line of action like this, and so it's the perpendicular distance. This is the perpendicular distance, sorry. So the moment about point A is the force by this distance D. Okay, the distance and the moment should always be perpendicular. Now we can also do take the components of the force. We can do the components of the force like this, Fy and Fx. And multiply. Now the moment caused by Fx is 0 because it passes through the point, and multiply Fy by the distance, by this distance. So you will get the same answer. Okay. Now this type of a question repeats in the FE exam. So the key to the solution, you have to look for the word perpendicular. So for this one, the horizontal component of the lever arm This is not correct because it's the horizontal component. So it should be a multiplication of force by distance. Now the vertical component of the force, this is not correct. The perpendicular distance from the pivot to the force's line of action. So this is the correct answer. Now for this type of a question, when it asks about the moment, look for the word, if you are in a hurry, you don't have enough time, just look for the word perpendicular. So it should be the perpendicular distance multiplied by the force. The next question, 16. For a circular shaft undergoing torsion, the angle of twist per unit length is primarily determined by which of the following? So this is a shaft subject to a torque. So for the shaft subject to a torque, we know that the stress is proportional to tau is proportional, or tau equals TR over J, where tau T is the torque, R is the radius, and J is the polar moment of inertia. So we have to look now the twist, the angle of a twist. It should also be proportional to the torque and to the polar moment of inertia, or to the shear stress. So Young's modulus and moment of inertia, no. Shear modulus and polar moment of inertia. So here we see that there is polar moment of inertia, so this is the correct answer. So the correct answer is B, because it contains polar moment of inertia. So the correct answer is B. Next question. So which phenomenon describes the gradual deformation of a material under constant load over an extended period? Now, deformation under constant load, under constant load is called creep. This is definition. Okay? Deformation under constant load is creep. This is from material science. So this is creep. This is definition. Okay, next question. When analyzing a composite beam made of two different materials, the transformed section method is used to convert the components, convert the composite section into an equivalent homogeneous section for analysis. So this looks correct, makes sense. So we want to convert, if we have two different material, so we want to convert, to simplify the analysis, we want to convert the cross section to a homogeneous, to an equivalent homogeneous material. So A is the correct answer. The next question. When a force is applied off-center, on an object, creating moment, the magnitude of the moment is determined by multiplying the force by. This is very similar to this question, which is still here, this drawing. So always the moment should be the force multiplied by the perpendicular distance. So in this type of question, this question repeats actually in every FE exam. So you should look for the word perpendicular. The force and the moment should, and the force and the distance should be perpendicular. So the correct answer is B. The perpendicular distance from the center of mass. Yeah, the perpendicular distance. So the correct answer is D, because the perpendicular distance from the center of mass to the force's line of action. Okay, this question repeats. And when you are asking about the moment, you have a moment and a force. you should look for the word perpendicular. Next question. The rotational kinetic energy of a body in constant angular motion depends on. So only the mass, rotational kinetic energy, the mass of the body, only the angular velocity, the moment of inertia, and the square of the angular. Okay, so this question also repeats. So let me show you how to get the correct answer to this question. So this question repeats in different FE exams. So we'll see now how it is solved, but you can memorize the solution to save time. So kinetic energy, this is about kinetic energy. So we know that kinetic energy of a moving object equals half mv squared, where Ke is kinetic energy, m is mass, and v is the linear velocity. So we know the relationship between linear velocity and rotational velocity, that v equals omega r. This is r. V equals omega r, where omega is the rotational velocity or angular speed, and r is the radius, and v is the linear velocity. Now we substitute v into the kinetic energy equation. So kinetic energy equals half m omega square r square. I just substituted v omega r. So now we know that mr square is moment of inertia. Mr square is moment of inertia. So kinetic energy equals moment of inertia multiplied by the square of the angular velocity. So the correct answer is C, the moment of inertia and the square of the angular velocity. Again, this question repeats in the FE exams, so you can simply memorize the answer without doing the calculations in the exam. It is simply the moment of inertia multiplied by the square of the angular velocity. So next question. Which of the following conditions must be satisfied for a rigid body to be in static equilibrium? Also, this question repeats in the FE exam. So for static equilibrium, summation of forces should be zero, and summation of moments should be zero. The equilibrium equations, when you analyze an object in static equilibrium, you apply sigma fx equals zero, sigma fy equals zero, and sigma moments equal to zero. So summation of moments should be zero, and summation of forces should be zero. So the sum of forces acting on the body equal to zero, this is correct. The sum of moments acting on the body equals to zero, this is also correct. Only the vertical forces must be balanced, this is not correct. So the answer is D, both A and B. So this is the correct answer, which is A and B. The summation of forces should be zero, and the summation of moments should be zero. Next question, which statement best describes the principle of moments in a statically balanced system? So the choices are: the sum of clockwise moments and must equal the sum of anti-clockwise moments. So the summation of moments in the two opposite directions should be equal. So the net moment is zero. So this is the correct answer. You can look to the other. The sum of all moments must be greater than the applied. This is nonsense. Moments don't depend on the distance. This is also does not make sense. Only the moments at the supports are considered. This is also not correct. So the summation of all moments clockwise should equal the summation of all moments anti-clockwise. Many times in the exam, you can eliminate some of the options or sometimes several options just by common engineering sense. So the next question, according to Newton's second law of motion in dynamics, which equation is correct? This is Newton's second law. Also, this question repeats. So we know that Newton's second law is force equals ma. Force equals ma. That's the force equals mass by acceleration. Force equals ma. This is in Newton's second law. This is a very basic question. Force equals ma, where force is the force in the Newton or pound feet, and m is the mass and a is the acceleration. So force equals mass by acceleration. This is very basic question, and it repeats actually in the FE exam. The next question, in the context of friction, static friction is best defined. You know that static friction is the force, is the frictional force when the object is at the verge of moving. So it is the frictional force that opposes the initiation of motion between two surfaces at rest. So this is the correct answer. You can also look, if you are not sure, to the other options. So the friction that acts only when objects are sliding, this is not correct because when the object is sliding, we will have the dynamic friction. Now, of course, that increases indefinitely with the applied load. This does not make sense. There is no force that increases indefinitely. A constant force irrespective of the contact surface. This is also nonsense. So you can eliminate all the other options from by common sense. But if you are sure, or you should be sure, the first option is correct. Now the next question: when analyzing truss system, which method is most commonly used to determine the forces in its members? Now, when we analyze a truss, now we have two methods of analysis. Either we use method of joints or method of sections. But the most commonly used one is the method of joints. Now the method of sections, now the method of joints is most common because you can analyze or you can determine the force in more than one member by taking one joint. Now the method of joints, the method of sections is suitable if you want to determine the force in a selected member, in only one selected member. Now, if we want to analyze the forces in all the members, so the most common method is the method of joints, but the method of sections is still correct. Okay, but the which method is most commonly used is the method of joints. So the next question: the moment of inertia in dynamics is described as. So this is about the definition of the moment of inertia. So a measure of an object's resistance to changes in its rotational motion about an axis. So this is the correct answer. But let's also look at the other answers to see if, in case you are not sure, you can eliminate, if you can eliminate the total mass. So inertia is not mass. So B is not correct. The linear acceleration dO again. So this is acceleration. Acceleration is not moment of inertia. The ratio of force to displacement. Force to displacement is not inertia. So if you are not sure, you can also eliminate B, C, and D by common engineering sense. So the correct answer is A. So the next question. Let me remove these. So in statically determined structure, the analysis is simplified because now in statically determined structures, we can analyze the structure by the three equations of static equilibrium. Sigma fx equal to 0, sigma fy equal to 0, and summation of moments equal to 0. So the correct answer, there are more unknown forces than available equations. This is not correct, because the number of unknowns should equal the number of equations for statically determinate structures. The structures, unknown forces can be determined solely by equilibrium equations. So this is the correct answer, where the unknown forces can be determined by the equations of equilibrium. So the structure is designed to be flexible, and that is not correct. It relies on experimental data, and also this is not correct. So sometimes, again, if you are not sure, you can eliminate some of the choices to make your options list. So let's go to 99, the next question. In dynamic analysis, the term damping refers to. So again, this question, if you are not sure, you can eliminate the questions. So now from the language, damping is reduction. It is not amplification. So A is not correct, regardless whatever is in A. Amplification of oscillatory, so damping is not amplification. So reduction, B, the reduction of vibrational energy due to resistive forces, so it looks correct. Damping is reduction. So let's look also to the other options. So the initial surge in velocity when motion begins. So oscillatory motion is not initial surge in motion. So the theoretical maximum energy, again, oscillating motion is not energy. So you can eliminate actually A, C, and D, and the correct answer is B. And you can also say that from common sense, because damping is reduction, so the correct answer is B, without spending a lot of time. The next question. In bending analysis of allotted beam, which factor does not directly affect the bending moment at a specific location? Now we know that the bending moment is always force by distance, by perpendicular distance. So which of these does not affect the magnitude of the applied load? So this is not correct, because the applied load affects the moment, the distance from the load to the suction, the material's yield strength. So this does not affect the yield strength, does not affect the moment. The beam's support conditions. So the support conditions affect the moment because they affect the type of the magnitude of the moment. So the correct answer is C. So the material's yield strength does not affect the moment. So that's all for today's video. If you have any question about the questions solved in this video, please let me know in the comment. If you have any problem you want me to solve, please send to me in the comments, and I will consider in the next videos. Thank you for following my channel, and I look forward to seeing you in the next videos.